rotate them differently, but they're all exactly the same. And because they're all marked as static, you're getting one draw call because it's batching all of that together. It's basically thinking of that as one material and one thing it has to edit. And so you're basically, I think maybe one, maybe two draw calls it might get, and that just depends on the CPU. But when you do that, you save a lot. I did the exact same thing with the wall back here too. I did one texture for the wall, and with that texture, open it up here, I've got a couple things. Yeah, cool. I've got the wall itself, which I use to do this repeatable texture for the wall, and that's this right here. And then for the top of the wall, I used this repeatable texture right here. And then I took that model and I cut it down and did a variation on it, and I used this area of my texture to do kind of like that broken part of the wall, right? And then from there, I wanted to do a column of the wall too. And so I made this third model, oh, whoops, get back out of there. I made this third part of the model, which was this column right here, that I used the exact same texture to kind of use the UVs and repurpose that texture to make more elements. So from there, I was able to get three kind of unique models. I did a broken wall, I did a flat wall, and then I did a column with a cross on top of it that are all using the exact same texture. And that's a one draw call. And you have all these elements. You can do all kind of unique things. Yeah, and do really, really cool stuff with it. So that's just a really good tip, and you want to be very cognizant of that when you're building your levels, that you can take all these pieces, combine them, combine as much as you can to build a lot of unique pieces with one material.
And save on performance, because remember that draw calls affect CPU.
Absolutely.
Reduce that all out. Very cool.
And these work really great when you're doing things like castles and other things like that. You want to make sure that you just throw all that stuff into one material that all these objects can use. You're really going to save on your draw calls, and you're really going to get great gains out of the performance of your game.
That's cool.
Well. Yeah.
Very cool. So very important tips to remember.
Yeah.
Let's move on to some other tips that we've got here. Compression. Compression, typically very easy inside of Unity. You can compress inside of Unity per platform. You can figure out which devices you want to target. So if you're going to be going to Windows Phone versus Windows Store versus iOS versus Android, etc., you can change your compression on there. Now, universal apps don't support compression per platform, and I'll show you this in a second. And this affects not just Windows. There's other platforms that have the concept of universal apps. But the idea is that when you want to take one texture, it might be a high resolution on a, let's say you're going to be running on a PC. If you're going to be running on mobile, you want that compressed down quite a bit. And inside of Unity, let's take some of those textures that I had before, like some of those platforms. If I click on them right over here, Unity shows me the quality right now. So let's say I'm going to build for the web. I might have, right now I have a default size of 1024. But let's say on Windows Phone, I want to override that value and come down to maybe 256. Let's just look at that real quick here. Kind of notice the resolution that's on here. I'm going to override for Windows Phone, and you just drop this value down here. So I'm going to take this just for the effect so we can see it more. I'm going to chop down, that's 3.8 megs. And then how do you change your actual platform to see that? In your build settings inside of Unity, Control-Shift-B or File Build Settings. When we come in and we change them, right now we're defaulted to Windows Store. If I want to go to a standalone build, I would switch a platform there, or down here to Windows Phone, switch platform. Let me actually go back and switch Windows Store since I'm on Windows Store here, and change that down. There we go. Because that's my default platform I'm building for. Now we see the effect. That went from near 3 megs down to 15K, and we can see the size and quality has been reduced quite a bit. So I probably wouldn't use it on anything with a big screen. This is probably a good setting for phone. The idea is on these settings per platform, whatever platform you're exporting to that Unity supports, you can override that per platform and change those settings up a bit. So it's kind of a little bit of experimentation. Alchemy Labs has a really cool product called the Multi-Platform Toolkit, and that kind of gives you an easier way to support compression inside of a platform. So for example, a universal app in Windows where you can have one build that's going to target inside of Unity, you're going to export universal apps for Windows Phone and for Windows 8.1. What you can do is separate them out inside of it. You can say, oh, we're going to Windows Phone 8.1. I want maybe this texture, and if we're going to be going to Windows Store on Windows 8 style, maybe bigger devices than a phone screen, I want to target this size texture. So you can definitely mix that up quite a bit on there.
Just to show you really quickly, if you want to cut back to my screen, what we were talking about earlier with the light probes, this is the effect you'll get. So when you look at your character on the screen, as he runs around, you can see there's kind of that general ambience out here, but as he gets closer here, he starts to light up. So you'll kind of get those vertex shading on your character where it lights up and kind of just gives you a little more of that ambience as he runs around.
I see.
So he's kind of general ambience, and he goes here and he starts to light up, and you can see those colors kind of hitting him. So just, light probes are really, really good to give you that added kind of dimension to your characters and a little bit of shadow and feel to them. So just to show you
some added info. Very cool.
Just some added info to kind of
Very
give
cool.
you an idea of what that looks like.
Awesome. So back to compressing textures. We can change that real easy inside of Unity. Just check those off and change them per platform. Audio is easy as well. Unity supports a bunch of different audio types: WAV, MP3, OGG or OGG. So the idea is that if you have long bits of audio, you kind of want to rethink that strategy a bit. Either you have to highly compress them, and I know you came across this when you were playing kind of full songs on long audio tracks. You found out that you had to really...
Yeah, you want to keep your audio tracks down to basically loopable, maybe 30-second tops tracks, because when you have these very, very long songs that play, it's a major memory hog, especially for mobile devices. You're going to get major, major memory loss that you could potentially use for other things like graphics and everything else when you have all that memory being filled up by this audio. And it also reduces the loading time a lot on your game. So when you have these huge songs, right, that are in your level that you have to load, and you want to reduce that, just put it in a loopable track. Makes it a lot easier. The levels will load up a lot quicker because it doesn't have to load in all that audio at once.
Some folks might notice that on the settings for audio in Unity, if we switch back to the slides here, this guy right here, stream from disk. That sounds like, well, hey, I don't have to load it all in the memory. The purpose of this is to increase, to make your game load faster as opposed to have to wait for that audio. It plays faster. The downside is there's a lot of hits to storage, and that is also a drain on your game. So there's kind of trade-offs as a best overall strategy. Like Matt said, you want to keep these clips to lower length, loop them, and then switch in and out other clips to kind of mix it up a little bit, right?
Absolutely, absolutely.
All right, let's talk about coding techniques next. So in Unity, you can do all sorts of coding optimizations. As a general rule, some folks might say don't premature optimize. So there's all sorts of different tips and tricks and different times you may or may not want to use these. So I'll just talk about some of the basic ones here and kind of when you might want to use them. Remember that inside of Unity as it stands today, you're going in your code from this kind of managed code over to native code back again. So if you say to Unity, hey, I want to do something in code with this game object's transform, it's going to the native engine, getting an object and sending it back to you. And anytime you cross those boundaries, you hurt performance. So we're going to show a way that we can cache those up front. When you use techniques like GameObject.find, they scan every object in your game to try to find an object. They're very slow as well. Component references. We looked at in a demo of getting a reference to an animator component. In those, if we're constantly saying, hey, get me my animator component and do this with it. Give me my animator component and do this with it. Over and over and over again, maybe multiple times a frame, that's going to really kind of hurt performance. So you can cache these references up front. We'll get some code ways of doing that. In the editor inside of Unity, we can cache out a reference to there. We did that yesterday in the 3D game. We basically drag and dropped our little text box into the Unity editor, and I'll show you a code example of that. And ideally, you want to avoid lookups and loops. Not trying to go back to Unity and asking for data in a loop, maybe inside of your update frame. Since it gets called so many times a second, you don't want to loop inside of your update calling out as well. And also, object pooling, huge. If there's one thing to take away from today, object pooling. Pull your objects, pull your objects, pull your objects, and you say, Adam, what is object pooling? Well, I'll show you that in code. Let's hop over to a code demo here. Yesterday in ZPS, we were doing things like spawning out all of these zombies one by the pumpkins, one by one by one. These guys all start coming around. Let me
Zombie pumpkins?
Zombie pumpkins. Clear this guy. So all these pumpkins that were coming out, they were all being spawned at several times. I would destroy one, it would go away, it would get destroyed, new ones would spawn. That's very, very, very expensive for performance. Because you have to spin up new objects every time. In addition, you have to, the runtime will do garbage collections every now and then. And when it does garbage collection, in your game pauses. So you want to allocate as few objects as possible. The idea is you want to use...
When we were initially testing this, we had the pumpkins just kept coming. There was hundreds,
and my
hundreds,
system
maybe 200,
crawled.
300 pumpkins because it just kept spitting them
going,
out.
and,
so it started great. The game would start great. It would run like super smoothly. But then as those pumpkins started coming out and they started filling up the screen, you saw this major performance hit, and then it was like running like a dog. It was just running so slow. So
I got down to like 4 frames a second here.
Exactly. So this is what object pooling is all about. You kind of want to limit the amount of objects that are on the screen at once. It kind of counts up that, and basically this is what you're doing.
Yesterday, to your point, this is exactly what we were doing here. We're basically coming in here and just constantly instantiating over and over and over again in a loop. Create the number of zombies for us per wave, then we waited a little bit, created another wave. I'm sorry, pumpkins. Zombies on the brain.
Zombie pumpkins.
So this is in the code that you're going to be able to download. I have spawn without pooling. That's what I was doing yesterday. Today, I'll show you my spawn with pooling. And I'm using one here called Trashman, which, just to show you the URL here, was also by the fellow from Prime-31. You can write your own object pooler. You can download a bunch from the net. There's tons of them out here. This is just one I kind of like how it works. It's pretty easy to use. All you're doing here, rather than getting a brand new object, what you're doing is you're downloading the Trashman component. You're adding a game object to your scene. I called mine Trashman. And you have this Trashman script over here.
Great name.
It's a recycle bin and a trash man. You drag your prefab on here. So I took the pumpkin, dragged it on here, and it created a recycle bin for a pumpkin. Said, all right, how many do you want to pre-allocate? Well, I'm matching this to my wave size. I want 12 pumpkins to come on my screen at once. And here I'm saying, you know what? I don't ever want to go above 12 pumpkins. I'm going to wait until that player has to destroy them. Even if it's time for the second wave, what this does is when you ask the pool for another pumpkin, if there's already 12 out, it's just going to return null. There's not one available.
So without having that checked, it'll do 12 at a time, essentially, and then that could add up and be even higher than 12. But if that's checked, it'll only make sure that there's only 12 at once.
Yep, it can go higher. In that case, then it has to allocate more. What I've done in this case is I've said I've got a hard limit of 12. Do not give me any more than 12. Now, this number doesn't have to match the above. I could say start out with 12. I could make this 20, and then it's going to cut off at 20. So kind of fool around with it. I'm going to make this match my wave size just for, I think, for performance. It makes sense to me that way. In the code, it's really easy. We say, Trashman, give me a pumpkin. That's all we do. And then, let me search here, and I will show you where we despawn. Once we kill a pumpkin, we call its die method, and all I do here is I despawn that. Now, I could respawn my particle systems here. This is kind of a no-no, I would say. I should actually recycle my particle effects here. So right now, Trashman despawn my game object. Now, whenever I want to create a new one again, I spawn it, and then I just happen to reset the values on there. And if I look at my pumpkin here, I just have a little reset value that comes in here, sets its health back to its initial health, stops any running coroutines, just to start those values out again. You always want to make sure you reset your object's health or whatever values you need to reset in there before going again. Now let's run over to Visual Studio here again. Stay in Visual Studio, I should say. And I just want to show you a code optimization script. Just a couple techniques in here. So one, up front, we did this yesterday. As soon as my object, before its first frame is ever even rendered, when this object first starts up, there's one called before start, called awake. We can use void start. This happens right before the first frame. Other objects are generally initialized by this stage. As of now, with the awake method, I only know that my object is awake. I have no idea if there's any other objects instantiated or not. In this case, it's early on in the process. I know I can get a reference to my own animator component. I'm going to use this all over. So I want to get that early, cache it up front, so I don't have to go back and forth asking Unity for it. Now this here, another one. When my game starts up, I'm doing this in start because now I know other objects likely exist at this point in time. In other words, I know my player is going to exist by the time my start method is called. Start is right before the first frame for this pumpkin is rendered. So I know that my main player at this point in time is already awake. It might not be rendered yet, but it's safe to call it here. I'm saying finding my player, I'm caching that reference. Now anywhere in my game, in this code, I can use player without having to search for it all the time. You'll find that some folks will do things in their update method like that. Every frame they're searching for it. Very, very, very bad for performance. Do this up front, cache those references, use them later. Again, caching reference here, I'm calling transform.position every time. The ideal way, and this is being called an update, it's happening every frame. The ideal way here is to go up top of my code and do something like this. Cache to reference that transform. And I can use that later on without having to go back and forth between my code and Unity's native code. Saves on performance there. So all these places here, rather than using transform, I would be using my cache transform like that. So that's one way to save on those calls.
It's a good tip.
Now, finds. Just like we found our player in the beginning. So let me scroll up here. On start, I cached a reference to my player. I'm doing the exact same thing here. GameObject.find zombie kid. You don't want to do this every update. GameObject.find searches through every object until it finds one. Now this one here is a little bit more performant. This only searches objects that have a tag set on them. Find GameObject with tag, I'm looking for my player. Again, I don't want to do this in update. I only want to do this up front. And as I showed you in the beginning here, my animator component, so if I right click and I go to definition, I'm just creating a private variable here called animator. And when I wake up, I'm getting a reference. I'm calling get component. So it's a little bit slower. It's got to search that object for that component. I don't want to do that every frame. Cache it up front. And then wherever you use it in your code, you can just use that private variable and reference it. A couple little tips that go a really, really long way. Object pooling. Let's go back to that slide here. Object pooling and not searching for objects in update. Cache those references can really, really help for performance.
Great.
All right, let's move on to almost to the last subject, terrain and skyboxes. We'll just talk about real fast here. Unity terrain, it's got a really cool terrain system in there. When we get to the demo for the next section, reducing geometry, you'll show a quick demo on there.
Absolutely.
It's a cool system, but it generates many draw calls. So you can experiment with some of the built-in settings in Unity. They have some of these settings we can see on the slide here. Reducing pixel error can actually reduce the number of draw calls for terrain. Terrain is really hefty. You can drop a terrain in your scene. Next thing you know, you have 300 draw calls. Really draw call heavy. There are some really cool third-party tools, T4M, Terrain for Mobile, to help optimize your terrains. You're going to do a demo with TopoGun.
Yep.
Skyboxes. Yesterday, we looked at creating a sky in our world. Skybox has 6 images that get tiled around your world to make it look like you have a sky. That's 6 draw calls. KGFS Skybox has a kind of a cool little plugin that you can use, get from the asset store, that will reduce it down to 1 draw call. There's probably some manual methods you could do as well. For me, I love using the asset store. If I find a cool package on there, I download it and I use it quite repeatedly. In fact, virtually any studio, any developer I've ever talked to who's made professional games, they've got several assets they love from the asset store.
Great.
Lastly, reducing geometry. Some might say one of the most important subjects, this and reducing draw calls, right?
Yep.
Well, geometry, polygons and triangles in your game. It's important to know that polygons in your game are drawn using triangles. So when you model your character, you have what people refer to as polys in there. Those are actually drawn using triangles. Unity uses triangles. Your graphics card actually draws triangles. If we look at this cube on the right-hand side here, we can see this cube surface is actually 2 triangles.
Quad is 2 triangles.
Quad is 2 triangles. What a coincidence. So even 2D images use triangles.
And this is where that term tries, when you hear people go,
Tries.
how many tries are in your level?
Yeah.
What's the try count? That's triangles. It's just a nickname for triangles.
On the right-hand side here for the cool logo Matt created, Zombie Pumpkin Slayer. Guys, I didn't hear you. There we go. Woo! Look at all of these triangles that make this up. Even a 2D image uses triangles behind the scene, how Unity determines how to display this.
And
So-
I think you can edit those as well. They have an edit function where you can go through and kind of reduce the amount of points around an image if you would like to reduce those. You can also do that in a 3D program as well, like Maya or whatever, if you're casting basically a UV over a certain area. That's just one way to kind of optimize certain things if there are too many tries happening.
Cool. There's various tools you can do. You can do them manually. You can go into your favorite tool to do it. There's third-party tools like Cruncher. I'll show you a quick demo of Cruncher. Mixamo has a neat one. Decimator. Blender has one built in you can get called Decimate. There's third-party services. One of them is simplygon.com where you can upload your model up to a site. It happens online. Really, really cool. I mean, there's plenty of services out there that do it, different ways to do it.
Another term is retopologize. So you're going to hear that a lot.
Retopologize.
If you would like to retopologize your model, look for that in 3D programs, and that basically means it'll trace kind of a cage around a model essentially with a lower res, and you can kind of set that res and play with it depending on the package you're using.
Very cool. You can also draw a separate low poly model for your mobile. So maybe your console game or I would hope your console game has a different model than your mobile game.
Yeah.
Your console versus maybe your PC-based game versus maybe your mobile, tablet. You can have different models for that, each one with different levels of resolution in them.
Absolutely.
So you can do that manually or use tools like Topogun to kind of reduce that geometry. Level of detail. LOD is a pro feature in Unity, and that will allow you to take multiple models. So if you're up close to your zombie, for example, it's a kind of a high-def model. If that zombie's way off in the distance, why should you have to render all those, why should I have to calculate and draw all those tries? So you can use LOD, level of detail, saying if it's a certain distance away, use that lower res model. When it's closer, show this model. Now, LODs is a pro feature in Unity, but there are scripts and plenty of ways you can find on the net that you can actually do it manually inside of code.
And that's great for games where you have tons and tons of like armies from a distance or different things like that. There's a ton of games out there that do that, and they'll actually have these really low-res models and thousands of them running around. But as you get closer, they pop in the high-res version so you can see like what they look like.
Cool. All right, let's move to our last demo for this session, reducing geometry. I'm going to show you a little quick tool that I like to use inside of Unity. It's a pay tool, so keep that in mind. Sometimes folks like some free features. The two tools that we're going to demo, I think you can get a trial of one of them. There's, again, many different ways to do this. You can do it manually. The problem that I found when I started game development, I don't endorse any of these particular products. They just happen to be things that I use. Because when I started doing development, I would find assets in the asset store that I would like. I would download them. And what I would find is that some of them really downloaded with really, really, really high poly count models. So in fact, I was doing a game dev class, and this woman's like, oh, I got a shell from one of the third-party marketplaces for my game. And I looked at it and it was like, more than 50,000 vertices making up this little tiny shell. And I'm like, ooh, you have a couple of these in your scene, it's going to be really tough.
Yeah.
So, and that's the problem. Sometimes when you download these assets from the asset store, less on the asset store, because a lot of times you'll see the comments saying this is or is not good for mobile, but you get it from third-party marketplaces, and they're really nice models. And some of them are great for rendering scenes. You know, you might be doing an ad and you want these 3D scenes in your ad. That's different than running a game. In a game, you really want to optimize that.
And these are where you're going to use these decimator or retopology tools. There's two ways of doing it. You can use a decimator tool that's going to use an algorithm to kind of manually compute what it thinks it should look like if it were a lower res or lower topology. Whereas if you use a manual tool like Topogun, or I think there's a couple other tools out there that do the same thing, but that'll let you actually manually go in and create the cage yourself around your model, so you can actually specify where you want less detail and more detail shown. And that's great for character design and sometimes even terrain, which I'll show you.
Very cool. So switching over to my computer here, let's look at, we're going to do Cruncher on this guy. So I've got this kind of more high poly dinosaur here. I mean, look at all of those beautiful tries all over the place here. Tries everywhere. So you can come in here and specify a target quality, convert, and behind the scenes, see, now this is much more optimized here. Less tries making this up here. It's non-destructive. It will actually go into your base model, and you'll find that you get different versions of it created that have different different poly counts on it. So you can tweak this out a little bit, change them around, create different ones, experiment with the settings on here. Say, you know what, I do or don't like this particular. Maybe this is too much for me. In fact, I remember the zombie kid I was messing around with the other day, and I made took it way up, and he had like this little head that was this tiny little long cylinder. So you can actually go way, way overboard with this.
And sometimes you might not even, if you're doing low poly models from the start, like for example, our pumpkins and our zombie guy, they weren't exactly high res to begin with. They weren't a ton of tries. You might not even need to use these tools. These are specifically designed for when you have high res models, and then you actually want to reduce the poly count and make them more of low poly models.
Yes.
This is basically what that tool is intended for.
Look at this dinosaur, right? This was initially pretty, there were little tries all over this model. I just cranked these settings way down, and look at this guy now. This is probably pretty good for mobile. One might even say you could probably go down a little further, and you can see you get this nice blocky effect here, which you'll notice on a lot of mobile platforms, but generally it's a smaller screen, so you don't notice it as much.
And when you use tools like Topogun, if you notice what it did to his head, it kind of distorted his head a little bit in that model, and let's say you wanted to make that a lot more precise. That's when you use a tool like Topogun, where you could essentially retrace that head how you want to with less polys and get more of the look of the character that you're trying to do in more of a low poly look.
With that, why don't you show us a demo?
Okay, absolutely. So we're actually just going to use the terrain in Unity. Let's see. Do we have the terrain export tool in here? Let's see.
Want to show folks where they can get that?
Yeah, absolutely. So if you go online and just search for terrain export script for Unity, terrain OBJ exporter in the Unity community wiki, just look for this specific script, and it's going to give you two versions. It's going to give you the JavaScript and the C#. I always download the C# script. That's just the one that I always kind of use when I'm making my stuff. So you just want to download that script. And where is the download for that script here? Or actually, no, I think you just copy it and make a new script and paste it into there. So we'll just copy this script. And we're going to make a new script. We have to put into, do we have a scripts folder in here? Actually, we have to put it in editor. We're going to make a new script. We're going to edit this script. Yeah, just double click on it to edit. Have this load up. Can delete all this. Paste in our new script that we got. We want to call this terrain. There's a name for it that we have to use, which is exportterrain.cs. We'll save this.
Save that, rename it in Unity. Always good in Unity to make sure that your name of your objects, your classes, match the name that's inside of your editor. Sometimes you get some weird issues if you don't have it that way. And I think in this case, you can leave off the .cs on the end of that.
Oh, really?
I'm just kind of curious, did Unity take it off for you? Just out of,
yeah, it automatically does that.
Cool.
So I have my new script that I got down there. You see where you get it online. Just go to the Unity community wiki, look for export terrain. It gives me this new option at the top called terrain right there, and that'll give me my export function. So we're just going to make a new scene here to demonstrate what we're trying to do. I'm going to create some Unity terrain. So we're going to go to our game object. Component. I forget, where's the terrain at?
Game objects. Now they moved under Game Objects
change it.
3D.
3D object.
They just reorganized these menus.
So we go to game object, we go to 3D object, we're going to go to terrain, make our terrain. And this terrain's pretty substantial in size, so I'm just going to bring that down a little bit in my settings, which is over here in your terrain settings.
Click on the little gear icon there.
Click on the gear. 2000 by 2000 is huge.
Huge.
So I'm just going to bring that down to 200 by 200. And the max height we'll just put at 30. Maybe 60 for now.
Sounds good.
Go back in on our terrain. And then we'll use the terrain tools over here to kind of sculpt this terrain.
Okay.
And for the interest of time, I'm just going to do something really quickly here. We're going to get a brush, increase the brush size, go on here, and just start making some cool terrain, right? So we go through here, we make some terrain, and increase the opacity, do some bigger terrain, and we'll raise this higher brush size, make the height a little higher than that. We'll do 30 on the height. Just go through and really start making these large mountains and different elements on here.
Pretty cool, just sculpting out some mountains on there.
Just sculpting out mountains and just kind of creating that terrain you want to create.
One of the few things that you can actually create 3D by default inside of Unity is the terrain. The terrain tools are pretty cool. As I mentioned early on, Unity is really not a modeling tool itself, not a 3D asset creation, with the exception of the terrain tools that are inside of there.
So I'm just kind of making this little area that we want that looks a little...
Cool, very cool.
And just to show you some different, let's just make this down. We'll do some different height areas on here. All right.
That's pretty neat.
And that's always a good way if you're trying to make these kind of plateaus that you want your characters to jump down on and stuff. I always like to use the paint height tool, set the height, and then you can just kind of paint those heights. So you can have these multi-level areas that you want your characters to move on.
In other words, that just maxes out. You can't go any higher than a certain.
Exactly, and it'll even flatten it out for you too, which is great. So for here, I've got these different heights, and then I'm going to do another one that's maybe a little smaller. We'll do it at a 5, and maybe make it a little smaller so we can do like a crevice. I'll go through here, and we want this little kind of valley, right? And we want little areas in there that the character can kind of travel to, and what have you. So we have this little kind of canyon that we've created right here. Now, when you use a decimator tool, there's things that can happen when you use that tool. One, let's say I want this very, very precise.
Because it's like an all or nothing tool, essentially?
It's an all or nothing tool. It kind of encompasses your geometry and it does an algorithm and it just does it basically all at once, right? It's not very precise. It doesn't know that, you know what, I want the edge of my cliff right there, always, and it has to be that way because I want, when you use a decimator, it might actually round this out a little.